Sorry for the disturbance, guys. Okay, we will start the class. Okay. So yesterday we discussed something like concept called as carry look ahead adder, right? CLA. So before that, we thought something about ripple carry adder, right? So in ripple carry adder, like bits were calculating in the form of series, right? So ultimately, to tackle that problem, where if you are calculating C out in series means there will be some delays, right? So ultimately, to solve that delay, we are going to use carry look ahead adder. Okay. So what happens in carry look adder? As we discussed, there will be something called as generate signal, propagate signal, right? So what does this generate signal and propagate signal does? So generate signal is going to tell whether your inputs are going to generate carry out. Okay, so it's telling like I'm not going to check your every adder. Okay, I'm not going to check your every adder. I will just calculate whether your uh, inputs are generating the carry out. Okay, so basically it's going like without any steps. Okay, like how happened in RCA, right? Triple carry adder, it's going to like in series from one adder to another, the carry out was carrying, and it's going to say whether it's going to generate a carry in at the end, right? So but here we are skipping that steps. Okay, why? Because carry look at adder perform parallelly. Okay, so like it will check your inputs, and it will based on generate signal and propagate signal, it's going to tell whether your inputs are going to create a fiat. Okay, so yeah, with the use of this thing, what happens in your adder circuit? Okay, so it will make the processor faster. Okay, so basically it's going to increase the speed of carry computation. Okay, so carry will be calculated parallelly from all four adders based on inputs. With the help of this, the processor can perform other tasks, okay, on this carry out. So the processor speed of the processor will become more. I go. I hope everyone got my point on carry look ahead adder. Okay. So why we need this carry look adder? Can anyone say the answer? Why we need this carry look ahead adder? Any answers? Yeah, it performs binary addition faster than normal adder, but yeah, predict carry early. Yeah, yeah, everything is good. Okay, so the main use of this carry bit adder, right? You can do this perform in full adder also, and also in ripple carry adder also. Okay, so like what in that adder, what are you going to calculate? You're going to calculate input like one bit input only. But here what in multi sorry ripple carry adder, you can calculate even that we have some inputs, right? So in number of bits, right? But what happens if that input bits is around 4 bits or 32 bits? What will happen? Usually your computer won't communicate with only one bit, 0 or 1, right? It will calculate with many number of bits, right? So usually your inputs look like around 64 bits, 32 bits, 16 bits. Like this, your computer is going to like perform that task. So if that number of bits increases, you can't handle that using ripple carrier. Why? Because like there will be a number of steps for one bit. How many adder are going to use in that ripple carrier? How many adder you are going to connect series in series for that ripple carrier? So it makes the circuit complex. We can perform, but it will take more time. It will create more delay, and it the circuit will become complex. Okay, so rather than using ripple carry adder, if you use a carry look ahead adder for many number of bits, they can then you can perform task easily. Like you can calculate carry out for every bit in a one step parallelly. Okay, so this is how and this is why we are going to use carry look ahead adder. Okay, so just keep this point. So yesterday I did mention about something called generate and propagate, right? Do you guys remember on that topic, generate and propagate? Okay, look here, I'm going to explain. So as previously I said that, wait, I will show that. Yeah, what I said, generates generate signal are those will generate carry in. Okay, so it will check whether your inputs are generating carry in when you okay, it tells. Okay, so the condition will becomes if for generate signal to generate carry in, it will only generate when both of your inputs are one. Okay, so what does the generate signal says? The generate signal going to say whether your inputs are generating signals. Okay, so in this last case you can see that, right? What you are seeing, a AI and BI are equal, both are equals one, right? So at that time you only got your generate signal as one. So this generate signal is going to tell at what case your inputs are generating that particular carry in. Okay, now what is the case that your generate signal is generating the carry in both inputs are one, right? So just remember this point. Okay, so generate signal is going to tell at what time you are generating a carry. Okay, so when it, other than generate we have propagate also. So what does the propagate signal says? The propagate signal is going to say like when is your carry in is propagating. Okay, look here, I will give one example. Okay, can you guys see my notepad? Is my notepad visible? Yeah, wait. See, now you can see, right? Yeah, look here. Suppose think we have this output. Okay, this is input A. Okay, input A has 4 bits, and you have input B, which has 5 bits. Okay, sorry, it will cause you confusion. So I will just keep this as Yeah. Now you have input A and input B as 4 bits. What are the input A bits? 1 1 1 1, right? What are the input B bits? 0 0 1, right? So when you have your both input, like consider this as this is a LSB, right? So what you are looking like your first one year on the left hand right hand side of your right hand side, you are seeing some letters, right? These are called LSB and these are called MSB, right? So what this is saying, both input A0 and B0 are 1. So what will happen here? Your generate signal is going to get 1. Then if your generate signal is going to get 1 means what it's going to say? It's going to say that I have created a carry. So how your carry looks like? It will go to your another bit, right? So your carry will go to your another bit. So this is how it happens. So generate signal is saying that it's a condition which determines whether your both inputs are generating a carry in. Okay. So I hope everyone got this my point using this example. So when it comes to propagate signal, so propagate signal, what we have the condition for propagate signal to generate a signal, either one of the input, okay, either one of the input, it may be A or it may be B, either one of them should be 1, okay, so other should be 0. So what does this propagate signal is going to say? See, look here, now you have A1 is 1, B1 is 0, you have any one input 1, right? So what happens when you have one input, okay, one input as 1 and you have one carry. Now you have carry, right? So its propagate signal is going to say that propagate that carry to other next bit, okay. So it's nothing but it's going to transfer that carry. So okay, so how your output looks like here? Wait, I will show you. So your output of 1 plus 1 will becomes like this, right? 0 1 carry. So now we have one input as 1. So propagate signal is going to generate a propagate signal and it says that I need to propagate this carry into next bit, okay. So this like even if you add this, okay, now you add this 1 plus 1, okay, for now erase this. What will happen? 1 plus 1 will become 1 0, right? 0, and it will becomes like this, right? So you will carry one that. So instead of doing this kind of addition and something, so basically depending upon generate signal and propagate signal, you are going to determine whether to keep that carry or to propagate that carry, okay. So ultimately this is the use of this carry look ahead adder, okay. So basically we are doesn't even calculating, okay. So based on the input A and B, we are determining whether to we need to keep that carry or to propagate that carry, okay. So I hope everyone got my point. So this is what propagate and generate signal does, okay. So coming back to the concepts, we thought this how this works, okay. So like we need how without even carrying in, okay. So what does this code does? I said something, right? What does this equations do? This equation is going to determine what is the c out of that particular adder without even like taking input from another adder, okay. Basically based on this equation we are going to determine carry in of carry out of first, carry out of second, carry out of third, and carry out of fourth, okay. So I know, I think in previous class I explained this equation, how to write this equation, okay. Yeah, coming back to the like waveform or timing analysis. Okay, so this is just like here we have mentioned some this one, right, some test cases, okay, for the testing. Based on that test case, like else some other test cases we have taken here. So based on that, we are going to determine how this test case. Okay, let's take first test case. What we have here, we are A is 4 bits, and it is as 4 bits as 0011, in which MSB has 0 bit and LSB has 1 bit, right? And B is also generating 4 bits, which is 0101, right? So if you solve this, okay, first we need to determine, and we need to check for whether it's generating anything. Okay, C, take C in as 0, okay, for now. So based on this, we need to check whether your signal is generating any generate signal. Okay, so how you are going to determine whether your inputs are generating generate signal? When to keep generate signal 1? When both inputs, okay, see here, this, you can see that the first column, right? You guys can see that first column, right? Yeah, look carefully. Here we have something called 0011, right? So if you are going to create a generate signal, okay, so just think, if you have 4 bits of input A, 4 bits of input B, then at what bits you should get generate signal? It should be 4 bits, right? Because see here we had only 1 bit, so we are generating 1 bits of a generate signal. But now we have 4 bits, okay? So how your bits looks like? 0001. Why? Because generate signal is going to create a that generate value when your both inputs are 1 1. Okay, look here, your A0 is also 1, B0 is also 1, so you got 1. Okay, and for other bits, 1 0 0 1 0 0, so everything is 0. Why? Because it's a condition where to create a C out, you should have at least, you should have both input A and B as 1. Okay, and for other cases also. Okay, so now for you are going to create a propagates bits. Okay, in propagates we bits know that any one of the input should be 1, not both should be 1, and both should not be 0. Okay, so then only your propagate signal is going to create a propagate value. So now we have 1 1, it's 0 1 0 1 0 1 1 0 0 0. Okay, so like this, how we are going to create, like identify or determine generate value and propagate value. After that, sum. How to calculate the sum? Basically nothing but you need to just add these values. Okay, so here we don't have any C out. Okay, so you're getting 0. Check for this case also. Now we have C out as 1, right? Check this. Why we have 1? Try to solve it. Okay, so look here. You have A bits as 4 4 ones and 3 zeros and 1 1, right? For B input, 1 1 will become 0, right? So 1 1 will become, if you add 1 1 will becomes 1 0, right? Then you are going to carry that 1 to next one, then it will becomes 1 1 0 1 carry, 1 1 0 1 carry, 1 1 0 1 carry. Now you got 5 bits. You are now you got 5 bits, right? So that's why your sum is showing 40 and one bit is carry. That fifth bit is going to carry. Okay, this is how it's going to happen. And for generating a signal 1 1, it's look like this. And for propagate signal, where you are 1 and zeros are there, then you are going to get 1 there and 0 for like zeros condition or 1 condition. Okay, so this is how you are going to do analysis. Okay, so I hope everyone got the can look add adder concept. Okay, so next, carry select adder. So what is the use of carry select adder? So before going to that carry select adder, now we know CLA, right? Carry look ahead adder. Then we also thought that it will works on any number of bits inputs, right? So what is the use of this carry select adder? First, we need to know about that. Why we are going to learn this carry select adder? Before starting this concept, every doubt will comes, right? Like we know CLA is fast. Why? Because parallelly it works, right? It will carry C out. So the main thing that comes to your mind is that why we are not using CLA everywhere, right? We said like it's fast, it's work parallelly, and it will reduce some complexity, and you can easily, you can fastly you can calculate a C out, right? So why we are not using CLA everywhere? Answer is nothing but it is too complex. Okay, I know, I know why I'm saying this point. Okay, so what I said is right now it's too complex and it's take more area and more power. Okay, so why? The main question we will get after hearing these points is why? What is the main difference between this CSLA and CLA? Like how this CSLA differs from CLA. Okay, that is the main thing you are going to get when you hear that 3 points, right? I said something like for ripple carry adder, it takes too much time. Now, why he is telling like carry look ahead or also takes more area like that and too many gates, right? So, if you know this concept, carry select adder, then you will get answer for your every questions. Okay. So the main motto of this carry select adder is that usually we were predicting values in carry look ahead adder, right? So instead of predicting, we can check what will be the possibility of getting the answer, right? So that is the main thing we are going to do in carry select adder. So instead of predicting, it's going to check the possibilities. So we'll think, oh, there will be no possibilities. Like there will be only two possibilities. Either it should be zero or it should be one, right? So that are the only possibilities you are going to get inside carry select adder. So that is how we are going to do. Instead of predicting, we are going to check the possibilities. Okay. See, that's what I said. Instead of waiting for actual carry in, we compute two set of sums. Okay. One assume carry in as zero, and assume another carry in as one. Okay. So we are going to predict what will be the output. So how you are going to predict? I think this block diagram was somewhat wrong. So just don't look this, okay? So okay, before going to this CSLA concept, you already know RCA, right? Ripple carrier. What was happening there? It's going to perform task on bit 0, and based on that bit 0, it's going to generate carry out, and that carry out which is going to like another one adder, where it's going to perform task on A1 and B1 bits, and that's carry out will going to as carry in for another adder, where it's for performing task for A2 and B2 bits, like that it was working, right? So what was happening there? It's going to create a delay. So if what happens if your input is 32-bit, then obviously you're going to it will becomes very slow, right? So so just think like an engineer, okay? So what is the use of performing these kind of tasks? Like passing that carry in, like calculating that. What is the task? What is the main motto of or main goal you are performing the task? Can anyone say that in the chat? Why you are going to calculate that everything? Why? What do you need? Yeah, I know provides delay. To reduce the delay, we are going to use this kind of CSLA, CLA, right? Like asking you guys, what is the use? Why do we need to calculate that inputs to get what you are going to calculate this kind of things? Okay, what? The answer is carry, right? Because of carry only, you are going to perform this kind of task to get that carry. Like whether my input is sending any message to another bits like that. Okay, so this is how you are going. Your machine is going to think, and you should think. Okay, so if you think like an engineer, then the main thing you are waiting for is like what will be the carry is going to generate, right? Then what and what is the value that is carry is generating? Either it may be 1 or 0, right? So to find out what is that particular answer, you are doing performing this task, right? So look here, just take 8 bit as an example, okay? Divide them 8 bits into upper 4 bits and lower 4 bits, okay? Upper 4 bits and lower 4 bits is nothing but, okay, this is your bits. This is what input A and input B looks like, okay, which is of 8 bits. So what are you going to determine? You're going to split this into this all 4 1 is upper bits. This all 4 1 is lower bits. Okay, this is how you're going to split. Okay, what is the use of split? So the use of split is you're splitting this 8 bits into 4 upper bits, 4 lower bits, right? So if you need carry in, okay, what should the first block that's going to be calculated? The first block should be calculated is lower bits, right? So if you lower bits like this 4 bits, this 4 and this 4, if your lower bits is going to generate the carry, then it will be transferred to these bits, right? So what is the thing you are going to compute here? Your lower block, right? So what is your upper block is doing? Upper block is going to wait for that carry generated from lower block, okay? So if you are going to split like this, okay, after splitting just think what will be the CSA value, sorry, carry value you are going to get from lower blocks. From lower blocks, lower bit blocks, you are going to get either 1 or 0 as a carry, right? Other than this you are going not going to get anything. So what does this CSLA do? This CSLA doesn't like calculate everything, okay? So it's just going to check the probabilities. The probability is like either I get 1 or get a 0, right? So it's going to perform on that both conditions, okay? So this is how we are going to uh, define that probability and possibility of generating that particular carry, okay? So think here, suppose you have split your 8 bits into upper 4 and lower 4, okay? So wait, I will explain with a good example, okay? Okay, these are your A, this is A and B, okay? These are your upper and this will become your lower, okay? So these are the lower 4 bits of A, lower 4 bits of B, upper 4 bits of A and B, okay? So this is how it looks like. So what I said, if you are going to split, then this upper 4 bits will be waiting for the carry generated by these lower bits, right? So if you actually think, okay, the carry should always be either 0 or 1, right? So it will assume, okay, before even generating that carry, it's going to assume that I will get only two values. It may be either 0 or 1, okay? It's just think like that, and it will start its process for like what will be the outcome of these upper 4 bits, okay, before even generating the carry. So does it does. You A is 1010, right? And B is 001. Okay, these are your upper A and B bits. Okay, so what does it do? It's going to wait for what will be the carry of the lower bits, right? So think your adder now we will check for. we have only two possibilities. Either it may be one or zero. So it's going to check for each possibilities. Okay, zeros and ones. So if you are going to get carry as one, carry as one. Okay, if you are going to get carry as one, calculate the answer. Okay, one comes here. One plus one, zero, right? Zero. Here one carry zero, zero. So what you're going to get last at 1000, right? So now what will be your actual carry will becomes one, right? So it will becomes one. Think you have zero. What will becomes one, 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 one. So okay. So here your output like if you put a zero as carry in, okay? You assume zero as carry in. Then if you solve that zero here, look here. How do you solve that carry zero? Will place your zero like carry here, right? So what will the answer will become now? One, right? One plus zero, one, right? Zero plus one, one. One plus zero, zero, one, right? Everything will becomes one. So you are getting 4 bits input, 4 bits output. Sorry, for both 4 bits A and B, you are going to get 4 bits, right? That will be 111, right? So there is no other fifth bit, which is called as carry. There is no carry here, right? So you're going to assume carry as zero. If your Cn is zero, so this is what it's going to do. Okay, based on this only, like it will think both possibilities. What happens if I get this carry from my lower bits or this carry from my lower bits? Okay, so this is how it's going to work in CSLA. So like to better way of think this kind of concept, just think you're in a restaurant. Okay, then in that restaurant they prepare both veg and non-veg food, right? So the chef doesn't know like what you are going to prepare. It's like what you need, like that veg or non-veg, right? So usually what he does, will he will add everything ready, right? He will just serve based on your order, right? So that this is how it's going to work here also. It will check like it will split into upper and lower bits, and it will keep ready whether what will be your like C in from your lower bits. And if you see in is zero, then it will give like based on this condition, you will get like one. Okay, so just don't think you have written if you get C in as one, it will we will get C in C out as one, or C in as zero or C out as zero. Okay, just don't think like that. Okay, I'm just explaining this on this answer. Even you can get C in as one and C out as zero. Okay, so it all depends on this upper bits. Okay, so think like that. So I hope everyone got how this it's going to work. Okay, so next is nothing but like just as usual, you are going to create a design and a test bench. Okay, so based on that, you are going to prepare a waveform, right? So this is how carry select adder works. Okay, so I hope everyone got my point. And I will ask for this implementation, okay? CSLA and CSLA design and test bench implementation. I want it, okay? So I don't know how will you prepare this design and test bench. Just share your screenshot in the group, okay? So after preparing that, this is will be the task for today, okay? So I hope everyone got my point. So next class, like I will explain about why we need this carry skip adder, okay? There's another concept in called carry skip adder, okay? So this is enough for this class, okay, guys?